Guys, welcome back. In this video, we will learn about types of triangles, general properties of triangles, important terms associated with triangles. Then we'll see a special type of triangles called as equilateral triangle, isosceles triangle, and right angle triangle. Then we'll see about the congruency and similarity of triangles. Okay, let's get started. So, types of triangles. So triangle is nothing but a polygon with three sides, right? And what is the sum of angles? It's 180 degree. Okay. So the first type of triangle is called as acute angle triangle. So acute angle means angles less than 90 degree are called acute angle. Acute angles. So in a triangle, let's say this represented by triangle, if all three angles are less than 90 degree, then it is called acute angle triangle. Okay. So if you had guessed the second type, yes, it is called as the obtuse angle. Obtuse angle triangle. So obtuse angle is angle greater than 90 degree are called obtuse angles. So in a triangle, can all three be greater than 90 degree? No, right? Because the sum of angles itself 180 degree. Can any two be greater than 90 degree? No, right? Then the sum of those two angles itself will be greater than 90 degree. So only possibility is one angle can be greater than 90 degree. If one angle is greater than 90 degree, then it is called obtuse angle triangle. Okay. So we saw angle being greater than 90 degree and less than 90 degree. So we'll see something which is equal to 90 degree. It is called right angle triangle. So angled angle, you can call it anything. Right angle triangle. So here one of the angles 90 degree. Here again two angles cannot be 90 degree because then they only will add up to 180 degree. So right angle means 90 degree. Okay. The fourth type, which we'll see elaborately later, is called as equilateral triangle. So equi means equal. So here all angles are equal. If all angles are equal, then all sides are also equal. Okay. So what will be the angles? And they're equal to 60 degree, right? So the three of them will make 180 degree. Okay. So fifth type is called isosceles triangle. So in this two angles and their corresponding sides are equal. So for example, if you take this triangle, let's say A is equal to angle B. So let's say this is A and B. Then angle A is equal to angle B. Side A is equal to side B. Okay. The last type we'll see is scalene. So scalene is nothing special. So this means none of the sides or their angles are equal to any other side or angle. So here all sides are different, of different length. All angles are also different. So it is called as a scalene triangle. So next we'll see some general properties of triangles. So the first property is, let's first take a triangle. Let's say A, B and C, A, B and C. So sum of any two sides is always greater than the third side. So if you take any two sides, A plus B, it should always be greater than the third side, right? So you can simply visualize. So let's take A and B, this of length C. So now pick any point. Let's say this D. So AB is equal to AD plus DP, right? Suppose if you move this anywhere else other than on the line segment, this length is going to be greater, right? So the sum of this length is going to be greater. So that is how you can visualize it. So if they are equal, then they lie on the same line and they just form a straight line. And if you lift the point anywhere else, then the distance becomes greater, this total distance from A to B. So that way you can visualize and you can appreciate this fact. Okay. Second one is difference between any two sides is always smaller than the third side. So you take any two line segments, A, B and C, D. If you subtract them, what will be left? Only this part will be left. So it is equivalent to saying if A, B and C, D we overlap, it is the remaining part on the line segment. So again, like this again congruent to saying like with the first property, right? So but for a triangle it is outside the line, so the other side will always be greater. So this way you can think. And also see, you can see this also follows from here. So this we can also write as B is greater than C minus A, or A is greater than C minus B. So this way. Okay. So the third property is called the sine rule. So in this triangle, if you see, we can get A by sine of A is equal to B by sine of B is equal to C by sine of C. So I'm not right now not giving the proof of it, but later we'll see how to derive this as well. Okay, this is called the sine rule. Fourth is the cosine rule. So what we have in the cosine rule, a square is equal to b square plus c square minus 2bc cos a. Again, to appreciate this fact, you can try to visualize the triangles in the form of vectors. So for example, let's say this is C vector and this is B vector. This is angle A between them. So let's say this is the A vector. So A vector is nothing but B vector minus C vector. So the magnitude square will be B square plus C square minus 2BC and cosine of angle between them, right? Cos A. So this is how this is derived if you visualize them as vectors. Even without vectors, you can make constructions of 90-degree and use Pythagoras theorem to solve it. Similarly, for sine rule also you can do the same. So you can try to get these two equations as a homework. Okay. So the fifth property is the exterior angle is equal to the sum of other two interior angles. For example, let's take A, B, C and D. So angle D is equal to angle A plus angle B. So how do you prove it? So we know angle A plus angle B plus angle C is 180 degree because sum of angles of a triangle is 180 degree. And we also know C and D form a straight line. So angle C plus angle D is 180 degree. So you can just subtract both sides. You will get angle A plus angle B minus angle D is equal to 0. So angle D is angle A plus angle B. Okay. So sixth property is area of the triangle. So it is given as half into base into height. So we have a triangle, let's say ABC. So base is like any side can be taken as base, and its corresponding height is nothing but from the other vertex you draw a perpendicular. So this distance is height. So the area of triangle is given by half into base into height. So there is also another formula called Heron's formula. For this we need to define another parameter called as S. So this is called as a semi-perimeter of triangle. Perimeter is nothing but the sum of all sides. So let's say P is A plus B plus C. Semi-perimeter is A plus B plus C by 2, half of the perimeter. So once we define this, the area is given by root of S into S minus A into S minus B into S minus C. So I'm not going to derive this. You can again look up online and some other resources where it is extensively discussed. Okay. So other method can also be based on the vector. So the area between two vectors is given by its cross product. So it can be either, let's say I can take any two sides, A into B, let's say, then it is half into A into B. So then it will be half into magnitude of A to magnitude of B into sine of angle between them. So this is half AB into sine C. Similarly, we will also be able to derive sine A, sine B. Okay. So next we'll see some important terms associated with triangle. So first is called the median. So if you have a triangle, you take midpoint of any one side and join it to the other vertex. So then it is called the median. So it is the line joining the midpoint of a side to its opposite vertex. So there are how many medians for a triangle? There are 3 medians. Let's take M1, M2, M3 are the midpoints. Then we have 3 medians. So these medians have some special property. So first one is they divide the triangle into 2 equal areas. Why it is so? Because the height is still the same, but base has reduced by half each, right? So the area is half of the original triangle on each side, and the 3 medians meet at a point, and that point is called as the centroid of the triangle. So this meeting point is called as C. So other thing is centroid divides the median in the ratio 2:1. So if you say AC and CM, AC is to CM1 is nothing but 2:1. It is same for the other medians as well. So from the opposite point to the centroid, it is like twice the distance of what it is from the midpoint to the centroid. Okay. So next term is the height, which we already saw. It is also called the altitude of the triangle. So you have a triangle. If you draw a perpendicular from each side, each vertex to the other opposite side, then these are called as the height or the altitude. I'll call it EFG. So AG, BF and CE are heights of the triangle ABC. So it is nothing but the perpendicular drawn from any vertex to its opposite side. Okay, so these altitude also has some special properties. So first thing is all the altitudes again meet at a single point. Single point, and it is called as the orthocenter of the triangle. So another property is angle made by any side and its vertical angle form a supplementary pair. So what do you mean by vertical angle? So let's say if this is A and BF and CE are the altitudes, then this B, let's say this is orthocenter O, BOC, angle BOC is the vertical angle of A. So angle A plus angle BOC is equal to 180 degree. Similarly for angle B and angle AOC. Similarly for angle C. Okay, this is with the height or altitude of the triangle. Next we have the perpendicular bisectors. So if you take any line segment, the bisector is nothing but a line passing through the midpoint. So any line can pass through the midpoint. And perpendicular bisector is a perpendicular to that line and passing through the midpoint. So that is called as the perpendicular bisector. Similarly, if you have a triangle, and if we take the perpendicular bisectors on each side, then they all meet at a common point. So it is equivalent to saying that with C as center and EC or FC as and CG as radius, we draw a circle. Then all the vertices pass through the circle. So it is easy to see that from C all these points are equal and it is equal to the radius of the circumcircle. This circle is called as the circumcircle of the triangle. And we say the triangle is circumscribed inside this circle. So all properties of the circle holds for this triangle as well. So one such property is if you have this angle, let's say theta, is twice of angle E. So theta is equal to 2 times angle E. So this is one of the property. And the radius is this, the radius, and the midpoint of the chord FC becomes the chord, is nothing but the perpendicular bisector of the chord itself. Okay, so next we'll see about incenter. So incenter is nothing but if we have a triangle, if we have a circle inscribed inside the triangle, then the center of the circle is called as the incenter. It's the center of incircle. This circle is called as incircle. So this is formed by the angle bisectors of all the three angles. So A, B, C. If you have the angle bisectors of all the three angles, then they meet at a point called the incenter. So what is another property? So the AB, BC and AC are like tangents. So the circle, if we draw from the center to the tangent, they are perpendicular, and since it is the radius itself, it is equal. This distance are equal. So I'll take this distance as R1, R2, R3. So we have R1 equal to R2 equal to R3. So we can say the sides are equidistant from the incenter. For the circumcenter, what did we have? The vertices are equidistant, right? Here the sides are equidistant. And this R is called as the in radius of the triangle. Again, here whatever properties of circle and tangents hold, it is true here as well. So next we will see about equilateral triangle and its properties. Okay, this doesn't look okay. So we know the angles are equal and the sides are equal. Let's say the side is equal to length A. So first property is all angles are equal and equal to 60 degree and all sides are equal. So if all sides are equal, then we can get the area, right? So area, we can use any formula. If we draw a perpendicular, so before defining this, I will tell you all the above things we saw, right? The median, height, angle bisector, and perpendicular bisector. Are one and the same. For equilateral triangle because of symmetry, right? All these coincide. So if you draw 90 degree, it will be the, if this is like a height altitude I have drawn, but it is also a bisector, perpendicular bisector. So this will be a by 2 and this will be a by 2. You can use Pythagoras theorem to find the height. So h will be, so we have h square plus a square, a by 2 whole square is equal to a square. So h square plus a square by 4 is equal to a square. H square is 3 by 4a square. So h is root 3 by 2a. So what will be the area? Area will be half into base into height. So half into base is a into root 3 by 2a. So it is root 3 by 4 a square. So this is the area. So we have got the formula for height and area. So next, if we have a, let's take this. So if we have a circumcircle, we want to see what is the in radius. What is the radius? Circumradius. This is circumcircle and its radius. So radius of circle is called as circumradius. And it is denoted by capital R. So we know that for a equilateral triangle, all the points are also same. So the circumcenter, incenter, and orthocenter. Did we miss something? The centroid are same. So we already know this divides in the ratio 2:1. So we know the entire height. So r is nothing but 2 by 3 of h, right? And h we know is nothing but root 3 by 2. So this will be 1 by root 3a, which is nothing but a by root 3. And what about the in center? So have this. What can we say about the in radius? So this distance, let's say this small r, in radius. So this is nothing but height h, and this is a by 2. So what do we have? A by 2 whole square plus r square is equal to h square. So this is a square by 4 plus r square. H square is 3 by 4 a square, right? So r square is equal to 3 by 4 a square. Again, sorry, this total length is h and this will be 2h by 3. So this 2h by 3 whole square. So which will nothing but capital R, right? So capital R is a by root 3. So this will be a square by 3. So a square by 3. So r square is a square by 3 minus a square by 4, which is a square into 1 by 12. So r will be a by root 12. 12 is 4 into 3. So root 4 is 2. So this is a by 2 root 3. So this is the in radius. So can you see something? The in radius is a by 2 root 3. So if you compare r and small r, you see that capital R is 2 times small r. So the circumradius is 2 times the in radius. Okay. So next we'll move to isosceles triangle. So as I already said, in an isosceles triangle, two sides are equal and one side is different. Let's say this is A and base is B. So for isosceles triangle, the perpendicular bisector on the different side passes through the opposite vertex. So let's say A, B and C. So if you have a perpendicular bisector, then it will pass through vertex A. So this will divide B by 2, and this will be 90 degree. Right, so we can get the height h. So h square plus b by 2 whole square is nothing but a square. So h is root of a square minus b square by 4. Right, and what will be the area? Half into base is b itself into height h. So it is half into b into root of a square minus b square by 4. If we take 4 out, we get 1 by 4 into b into root of 4a square minus b square. So b by 4 in root of 4a square minus b square is the area formula. So this is with the isosceles triangle. Okay, next we will see the right angle triangle. So right angle triangle, what we have? One of the side is 90 degree. Say A, B and C. They needn't necessarily be equal. So here the height is easy, right? A itself is like a perpendicular or a height or altitude, and B is like a base. So area is half into A into B. So A and B are sides other than the hypotenuse side. So C is called the hypotenuse side. Okay, so area is nothing but half into product of the perpendicular sides. Right. So here Pythagoras theorem is again valid, which says a square plus b square is equal to c square. So if we know two of these, we'll be able to find the other side easily. Okay. So next we'll see congruency of triangles. So what does congruency mean? Congruent is same as saying equal or same. Congruent, yeah. So if you have a triangle and if you have another triangle, if they are same, all sides are same and all angles are same, then they are said to be congruent and they are represented by this symbol. So they should be same in all aspects. So later we'll see something called a similarity. So when we come to that, we'll see what is similarity and how it is different from congruency. But for now, it is enough to know about congruency. So we saw what is congruency, and we have certain conditions for congruency. So we'll see the first condition. So we have SSS, SAS congruency. So for two triangles ABC and EFG, we'll consider these two triangles everywhere after this. So if two of the sides and an included angle is same, then the two triangles are congruent. So you might ask, initially I said all angles and all sides should be equal, then only it is congruent. But now I'm saying just if two sides and the included angle. Again, what is included angle is? So if these are the two sides, then this is the included angle. Angle formed by those two sides. So you might ask, why now only this much you're saying? Because like this condition is redundant. So for two triangle, right? So if I just draw two sides and an angle, the third side is automatically defined, correct? Third side and the other two angles are automatically defined. So if side length, this side length and this side length is defined, and I also say the angle between them, then the other side is already defined, right? And the other angles are also defined. So like the full condition is redundant. So we can reduce just to these three conditions for two triangles to be congruent. So the other condition is again ASA congruency. So here the two angles and included side are equal, then it is sufficient. So if you have two angles, so one angle you have here and with respect to this included side, then automatically the meeting point is also defined and the other two sides and the another angle is also defined. So it is just sufficient to say two angles and included sides are equal for the two triangles to be congruent. The third one is AAS congruency. So AAS congruency, what we have? Any two angles and one side are same. So here ASA is the included side, so S comes in between. Here the S is coming outside, so it is the opposite. One side is opposite to any of the one of the angles. So if I take this angle and this angle, then I should take any one side, either this side or this side, because this is the included side. Without considering this, even if I consider this side or this side, still they are congruent. One side opposite to any one of the angle are equal. This is again true because if we have one side and we know one of the angle, we draw a line, and from here this angle we know. So if this and this angle are known, it is equivalent to saying I know this angle also, because sum is 180 degree always. So if I know this angle, then it is similar to ASA congruency. So from that we can again achieve the full triangle, and it cannot be different if we draw by this method. So AAS congruency also applies. And then we have SSS congruency. So if all three corresponding sides are equal, then the triangles are congruent. So again, I will not draw it, I will just paste. So this side is equal to this side, this side is equal to this side, this side is equal to this side, then they are congruent. In some cases they needn't be direct. So if this side is equal to this side, and this side is equal to this side, and this side is equal to this side, still they are congruent. But ABC, triangle ABC is congruent to, so A is same as F, triangle F, and B is same as G. So triangle ABC is congruent to triangle FGE. So once we prove it is congruent, then we can write the corresponding angles are equal. So that is the effectiveness we get. We just use three sides to prove the congruency. Then we also obtain the angles are equal. So this will be useful in many places. Okay. So the last one is SSA congruency. So in SSA what we have? We had SAS. So in SSA the angle is not included. So two sides and angle opposite to any one side are equal. So let's say these are the two sides, an angle opposite to any one side, either this or this angle. So if they are equal, then the two triangles are congruent. Why is this so? Again, we have one and we know this angle, so we draw a simple straight line, and from this point P we know BC, we just cut an arc of length BC, so we'll get this side also, and other two angles are also defined. So this way, like only one given the two side lengths and the opposite angle, only one triangle is possible. So any number of triangles you draw, they will be all equal in sides and angles, and they are congruent. So next we'll see similarity. So two triangles are said to be similar when they are proportional, when their sides are proportional. And angles are equal. So it is similar to saying you take a triangle and without changing any dimension, just scale it up or down. So then these two triangles are said to be similar. So you are just scaling the triangle, either bigger or smaller. Then two triangles are similar. So one property here is the angles are equal. So if we just give angle A equal to angle E, angle B equal to angle F, angle C equal to angle G, we cannot say they are congruent, right? Congruency does not hold for only angle case. So that's why we didn't have AAA congruency. We didn't have this. If you see, we had SAS, ASA, AAS and SSS, but we never had AAA congruency. Okay, so which means if angles are given, the sides needn't be of same length. They can be proportional. Okay, so first type of similarity we have is AAA itself. So if three angles are equal, then the triangles are similar. So I said the sides are proportional. So one property is AB by EF is equal to BC by FG is equal to AC by EG. So this property is true. This is sides are proportional. Okay. Next we have the SSS congruency. This is relevant from the definition of similarity itself, right? If three sides are proportional, then we have SSS similarity. So again, the same definition. So if this is equal, then we can say that the angles are equal. So the third type of similarity we have is SAS similarity. So if two of the sides are proportional, and the included angle is same, included angle is equal, angles are equal, then we can say the two triangles are similar. So for this, I'll take this. So if let's say AB equal to EF and BC equal to FG and angle B is equal to angle F. It's not equal, they're proportional, sorry. So AB by EF is equal to BC by FG. Then they are similar. So from this we can get all angles are same. So other angle also, angle A is equal to angle E, angle C is equal to angle G, and this will be equal to what else left? AC by EG. Okay. So this also, if you see if angle is same and these are just scaling, and this length also scales proportionately, right? So that's why this holds. And that's all the similarity. You can ask AAS why there is no similarity, but it is already included in AAA, right? Because if two angles are known, we'll also know the third angle. So AAA is already included. And with one side we cannot say it is proportional, right? We need at least two sides to show the proportionality. Okay. So you should also know that in similar triangles, the ratio of medians is equal to ratio of heights is equal to ratio of circumradii, which is equal to ratio of inradii, which is equal to ratio of angle bisector. So it is just same triangle, you are scaling it, everything scales proportionately. So that is what it is telling. Okay guys, that's it for today. It was a long class, I believe. Keep learning, keep revising these topics. If you have doubts on something, try to look up on the internet and try to find the derivation and try to derive them once or twice so that you get familiar with these. Thank you.